Good afternoon to all the participants in Nigeria. I am pleased to be here at the conference for International Center for Leadership Development in Nigeria. Good afternoon to the audience in Israel, which is connected to this presentation. And my topic will be today coordinated approach towards industrial cyber security. My name is Daniel Ehrenreich. I'm a consultant and lecturer, keynote speaker at conferences. I have over 44 years of industrial activity experience, and among this about 29 years in the area of SCADA and industrial control systems. And since the past 10 years, actually since the Stuxnet, I'm focusing on cybersecurity for industrial control systems. When we are speaking about cyber risks, we can no longer say who is looking for me, why I am a target, why would anyone attack me. And this is the reason why we are talking about three types of people and organizations. Those which were already attacked and they know that there is a risk. Those which are already under attack, but they don't know that the attacker is already sitting in the computer, waiting for the right moment, like a snake which is hiding behind the cabinet, waiting for the right moment to get out. The attacker is already there. And finally, organizations who sleep peacefully. However, they might be under attack as soon as tomorrow morning. So what does it mean? Every organization, every person, every university and every office can be under attack as soon as tomorrow morning. And this is the reason why you must be prepared for that moment. When we speak about industrial application, this is the main topic of this presentation. We all know that there are many industrial plants and utility plants in Nigeria, oil and gas, electricity, water, and so on. And we are looking at several types of organizations. We are looking at electricity distribution, water and sewage, oil and gas, chemical plants, food and beverage, even buildings can be under attack. Obviously, cellular communication networks, manufacturing facilities, public safety, siren systems, which must alert you when something happens. And also recently we see penetration to control system to smart cities. When we are looking at the organization facility, we are identifying 4 layers. On the top, you have the IT department, which is connected to the internet and actually this is the highest risk for the organization. Underneath we have 3 layers of the industrial operations, industrial control system. In the field level we have the sensors, the actuators, the remote terminal units, the programmable logic controllers. Above that we have the control system, the automation servers. And finally the control room, where we have the human-machine interface, the computers where the operators are sitting, they are monitoring how the operation is working. When we are looking, I would like to go very briefly through the principles of industrial control systems, because I assume that not everybody is strongly aware of that. So on the left side we see a legacy type operation which have wireless network, serial communication and even optical communication. On the right side you see a more modern system which have Ethernet communication, and these systems, as we will later see, can be under cyber attack much easier. So this is a very brief introduction. Obviously, when you're looking at power utility or an oil and gas facility, the situation is significantly different and the systems are much larger. Why are we operating industrial control systems? Because we are looking at operating benefits, what is good for the operator, what is good for the engineers, how they spend their time to manage the facility, and then financial benefits, how much money the organization can save, cost reduction, reduction of damages, better planned investment, and more. So definitely industrial control system is not a nice to have, but a mandatory system that you must have. If I'm looking at the very simple operation like a water pumping station, again you see on the left side the triangle which I explained earlier, and then you see the on-site facility where you have the reservoir, where you have the pump, a local PLC, and on the right side in the upper corner you see the computer where the operator is sitting. So these systems, they do supervision of the operation, they control the operation, they do adjustments in something is required, and finally data acquisition. These three words, supervisory, control, data acquisition, are actually the terminology SCADA, what we remember for many years associated with industrial control systems. When we are speaking about industrial facilities or any kind of computerized operation, we must talk about the new comer, the Internet of Things. Internet of Things is not really a new term. It's just a new name, because we have seen IoT devices back in 10, 20 years ago, but we didn't call them IoT. We called them remote sensors, machine to machine, and other types of names. So just to explain what is a IoT, on the right side you can see a picture which is monitoring the amount of products in the vending machine, and then you can receive reduced operation cost, faster response to fill up the vending machine, optimization, what type of products you are going to put, more accurate inventory, again what is necessary for weekdays, for weekends, and so on. And you can also develop interesting new business models using the IoT. And then we have the industrial IoT, which are similar but different, but because here we are talking about industrial operations like power plants, pumping stations, gas compressors, where we need to monitor the operation of the device, and we need to detect problems, and again the benefit will be more optimized operation and reduced cost of manpower, need for fewer experts, and so on, because everything is remotely monitored. Speaking about the cybersecurity risk, obviously adding IoT and IIoT is expanding the cyber attack surface. What does it mean, cyber attack surface? It means that the attacker have more opportunities, they have more entry paths to penetrate to the system. Why it is happening? Because these Internet of Things devices are simple devices, low-cost devices. They were not designed for cybersecurity. They do not have encryption. They do not have authentication. They do not have any of these solutions for preventing malware. Similar to the IIoT, it's the new approach. We have been there, but it's still a new approach. There are no standard protocols, many vendors providing low-cost computers, and and we see also a situation that the users, you buy a video camera for your home, you are not going to play with configuration and changing password. You just install it and believe everything is going to be fine. And the bottom line is increased cyber attack surface and increased risks. Just speaking a little bit about the trends, I already mentioned that these systems are migrating from serial communication to Ethernet communication. They have outdated hardware, outdated software. There is no proper documentation, and practically we see also use of commercial off-the-shelf products. In the past, we used to develop specific products for specific plants. Now we are buying off-the-shelf computers, which obviously are much easier for an attacker because he knows exactly how a Windows-based computer is working. He don't need to learn a specific computer built by Shell for specifically monitoring the oil plant, okay, or any other facility. So everything is standard and much easier. When we speak about risks, and in the bottom, in the orange color, you can see extended cyber attack surface lead to increased risk to ICS operations. Why we have that? Is because these systems were in the past not designed with cybersecurity in mind. I already mentioned increased use of commercial off-the-shelf products, increased interconnections among systems. And on the top, you can see the people factor. We will talk about it again a little bit later. The people who were not trained, the people who didn't learn, the people who act negligently. These are systems these are problems which increase the possibility of cyber attack, increase the cyber attack surface, and so on. So, let's go a step further and let's decide who is our enemy, who can attack us. According to the standard 62443, which I'm going to mention later, we need to worry about 4 types of attackers. So the lowest level is that we need to prevent unauthorized disclosure via casual exposure. Somebody makes a mistake, somebody leaves the computer on and going home. It's the casual. Nobody really planned to attack it, but I just passed by, I saw there is opportunity, a working computer, why don't I cause some damage? The higher level are attackers who are using simple means with low resources. They are not really professional. However, they have an intention. They want to try to cause a damage or outage, but they are not professional. If you go a step further to the higher risk, attackers using sophisticated means, however, they have moderate resources. They are capable, but they didn't invest money to buy the more sophisticated tools. So there is a high risk, but the SL4, security level 4, is the highest level. Here are attackers at the level of hostile countries, countries which really want to initiate the cyber attack. Things like we have seen happened already around the world. They made the aluminium factory, the Ukrainian power plant. Somebody really wanted to attack that facility using sophisticated means, extended resources, and obviously when you face this type of situation, you must be better protected. How an attack is starting? Attack may start in different ways, and we will talk about it soon. But remember the social engineering, the email that you receive with a picture of a friend from his vacation, the email that you receive that you won a prize or you can get a free hamburger. These are we call it social engineering, because people may just make a negligent decision, open that email, and suddenly that malware which is hidden in that email may penetrate to the computer and cause a damage to the computer. However, if that computer is connected to a large facility in a bank or in an oil platform or a power plant, that malware will further attack all the computers and all the servers. Remember what happened in 2017 when we had the WannaCry attack. How many computers received the malware? How was the damage to the organizations, to hospitals, to you name it? Because there was a ransomware attack, and those computers which were not protected, didn't have the right backup, had to pay the ransom in order to get back their file. But this is not really the topic of our presentation, because this mostly refers to IT type of facilities. I already mentioned that we need to worry about the attack vectors, from where the attack may come. So we need to talk about internally generated cyber attacks. We need to talk about internally generated means someone penetrated to your facility and he brought with him the USB stick which include the malware. Exactly what happened during the Stuxnet attack in 2010. It was an internally generated attack. Externally generated attack is always through the internet, through social engineering, through some type of phishing mail. What happened in Ukraine in 2015 and 16, it was externally generated attack. And finally, we start to worry about the supply chain attack. You are receiving a free software. You are buying a computer from an unauthorized reseller, and the malware is already inside in the computer. So 3 types of risks that you must worry about it, because something truly may happen. How the attack is happening? It's a good question. So let's put a very simple chart. It is representing the 7 steps of the Lockheed Martin cyber kill chain, which is a process that every attacker is taking, usually, no matter if it's the attacker against a bank or an industrial facility or even your home computer. You can always detect the seven steps. So it starts with a normal condition that nothing happens, but the victim is already detected. Somebody already decided to make an attack. Then at the next step, then the attacker is collecting information, what we call reconnaissance. The attacker is preparing the attack tool, what we call weaponize. The attack tool is delivered to your facility, to your computer, to your facility via email, via a USB, or somehow it is transferred to the facility, to the computer. Then we have the exploit, which is activating the attack tool within your computer. Then we have a command and control. The attacker is already managing your computer. The mouse is suddenly moving on the screen and you don't understand why. It's already the almost the final moment before the attack. The attacker is already working in your computer. Finally, execution of the attack, and then unfortunately a huge damage may happen. So need to remember, and when you think about how your organization is protected, always start to think about the Lockheed Martin cyber kill chain, although there are other additional more modern tools like the processes like the Mitre ATT-CK and others, but this takes a longer training and a presentation to explain these tools. Let's look at a very similar picture to what I already defined. On the left side you see the industrial operation, and you see in the red box the targeted PLC. That's the PLC which can activate the pump, which can activate the centrifuge in the nuclear plant. That's the PLC which can change the rotation of your power generator. That's the PLC which the attacker wants to attack. In the center you see the IT operation. On the right side you see the attacker which is connecting through the internet. He's compromising the firewall between the internet and the IT operation, and he may sit in your system between 150 to 200 days according to publications. Then he will compromise the firewall or any kind of defense between the IT and the ICS, and finally he will reach the PLC and the attack will start. Let's talk a few minutes about why handling of cyber defense for industrial control systems is difficult. It's difficult for a couple of reasons, and we all know these reasons, but somehow we are not taking care of it. We are not repairing, we are not modernizing our systems. The software and the hardware are updated. You cannot interfere with the ICS process. You cannot play with that while it's operating. And another topic which I already mentioned, that people do not have the right expertise, they do not have the right background in industrial control system and cybersecurity. So there is an urgent need to educate those people. They must receive training 1 day, 2 days, week, 2 weeks, as much as people can afford. Training is mandatory. Also, not remember that these systems are working, a water facility, an oil and gas facility. You are not just shutting them down, they are working all around the clock, every day, every hour. So what can we do? You need to have the right expertise in order to perform external complementing and compensating measures. It's like putting a guard in the front of the door. Yes, the door lock is broken, but if there is a guard, sorry. Yes, there is a guard, and he's protecting the facility from being attacked, so no one can penetrate there. So let's talk a little bit more technical details, but I promise you I will not go deeply to technical details. We speak about man-in-the-middle attack. Man-in-the-middle attack is where people are listening to your communication, collecting data. Then we can speak about the denial of service, or distributed denial of service, the DDoS, when somebody is transmitting huge amount of data to your servers in order to block the operation of your facility, meaning your customers, your suppliers, they cannot connect to the system. Somebody may steal business data. Why people are stealing data? People are stealing data for financial purposes, but they may also steal data for preparing a much bigger attack against your organization. And obviously the goal is always damage the equipment. And remember the Stuxnet 2010. The goal was damaging the nuclear facility in order to prevent its operation. So what can be done? Complementing and compensating cyber defense measures, with which I already mentioned. This is very, very important. So let's talk a little bit more technical details about the various types of attacks, how they happen, why they happen. First, I would like to talk about APT attack, Advanced Persistent Threat. 3 words, Advanced Persistent Threat. The meaning is that these attacks belong to the SL4, the highest level of security risks. When the attacker have motivation, when the attacker have resources, when he really can perform the attack. And the bad news, I can tell you that if any organization became a target for APT attack, the attacker will be successful. This is what you need to remember. APT attacks are always successful. I shouldn't say always, because there are miracles when something may happen and the attack is not successful, like what happened in Saudi Arabia with the safety instrument system. It was an APT attack, but it was not successful because of a last moment detection of this attack. So remember APT. Furthermore, I would like to talk about the term 0 day. People know a little bit about the 0 day. They know 0 day means that I don't have a defense against it, like I don't have an updated antivirus. But let's go dive a little bit deeper into this topic. And 0, actually we are talking about 3 different terms which are connected. We talk about the 0 day vulnerability. It is a weakness or a vulnerability in your computer, in your organization, which was not yet detected and no one knows about it. Okay? And however, what will happen, that suddenly somebody is detecting that vulnerability and he is able to inject the attack or transfer the attack because there is a vulnerability, and then we call it an exploit. Exploit means taking advantage of the vulnerability and activate the attack within the computer. Finally, we have the 0 day attack. 0 day attack is actually attacking your organization because there was a 0 day vulnerability, because someone was able to activate that vulnerability, and then finally an attack takes place. So 0 day is a very high risk. Why? Because at the moment there is a disclosure. For example, you receive an annunciation from Microsoft that there is a vulnerability in the Windows-based operating system and you must update your computer. So I want to say it very clearly that from the moment when the announcement is published until the moment that you perform that update, this is the high-risk situation. Why? Everyone can attack the computer, you exploiting that specific vulnerability. So very important to follow the instructions about Windows update, computer update, BIOS update, Java software update. As soon as you receive these messages that there is an update, you must instantly do that in order to prevent the attack on the computer. I want to say something very important. which is slightly contradicting to what I said. You do this update on IT computers, but you don't do it on ICS, industrial computers. Why? Because every change in the software may generate a safety problem. This is the reason why we always say that before you perform an update or industrial control system, you must perform inspection and make sure that that update is not causing safety risks. Very, very important topic, but again, I leave it for the longer presentation when I will explain in details why it is important, how it can be done, and so on. We all know that there are risks, but how to estimate the risk? How big is the risk? It's not a simple question. We need to look at two factors. We need to look at the impact. What can happen? My credit cards may be stolen, my computer may be encrypted, or there is an explosion in my facility. What is the impact? What can happen? And then the probability, the likelihood that something may happen. If I have a home computer, probably the probability is very low. However, if you speak about the industrial facility, the probability might be much bigger. Why? Because someone is interested to attack that computer and cause outage and cause damage. So if you multiply these two factors, you see that you are migrating from the green color, which is quite okay, to the red color when the high risk may happen. So always when you worried about your organization, when you worried about your facility, always ask these two questions. What are the impacts? And the impacts may be different, because if you speak about a large refinery plants where you have quite many industrial control systems, then obviously the impacts is not the same. For example, if you have a control system which is monitoring the level of the fuel in your storage tank, well, if that computer is not working fine, you may receive incorrect reading, and the problem can happen. However, if there is a computer which is monitoring the boiler, the steam boiler, or monitoring the operation of a refinery or a chemical plant, the explosion can happen, then the impact can be bigger. So we need to, when you speak about the impact and the probability, always look at your facility, and you look at differently at each and every facility, and let's see what may happen. So this is again a short explanation just to make sure that you understand that topic. I no longer want to scare you about cyber risk, so let's talk a little bit about how we are defending ourselves, because I always say that we must defend ourselves. So remember this triangle, we call it the PPT triad. The PPT triad is actually the umbrella for all types of cyber defense solutions. First of all, on the top, let's start from the top. People must be trained and aware of cyber risks. This is the most important defense that your organization must consider, and every person, engineer, an operator, a manager, every person must be trained and learn about the risk and the defense solutions. On the left side, you have the policies and procedures. So it's very important that the organization must have the policies and procedures to make sure that every person knows how to act, how to do things right, how to protect their facility. On the right side, we are speaking about the technology. Not be surprised that that the technology is the last topic I'm talking about. Why? Because deployment of new technology is always expensive. It requires shutting down the plant. It requires bringing expert to facilities. It's a complicated process. I'm not saying not do that. Yes, you must do it, but it requires years of planning how you are going to upgrade your facility. However, training of people can be done as soon as tomorrow morning. Compile a group, bring a trainer, and he will immediately do the job. Policies take a little bit more time, but definitely in a matter of 1 or 2 weeks, somebody will write or update your policy, so every person in the organization will know how to behave and how to protect the organization. So this is very important. Remember the PPT triad. During longer presentation, we will talk about the CIA triad, about the SRP triad, about the RDC triad, more things. But right now, remember the PPT triad. How we are performing the defense, I want to say, remember this. If there is one sentence you must remember from this presentation, there is no single cyber defense measure, no silver bullet, which can absolutely protect any industrial operation from a cyber attack. Remember that. What does it mean? It means that you need to have layered defense. You need to protect the control devices. You need to perform network security, the entire communication network, firewalls, DMZs, encryption, and so on. Then you need to protect all the endpoint devices, computers, controllers, smart sensors. Everything must be protected as best as you can, as much you can afford. Obviously, if you put more resources, it always can be done better. And then we speak about the perimeter security, the physical perimeter, the firewalls to the internet, and so on. So definitely a lot of work can be done and must be done in order to protect your organization and protect your facility. I don't want to go to details to this complicated picture, but instantly you notice that there is separation and segregation between different zones. The zones are somehow interconnected, but originally they are separated. Why it is important? Because if an attacker may penetrate to one of the regions, you must avoid that he will proceed to other sections in your organization. So what you need to do, you need to do mapping of the system. You need to understand where are the installations, which are the logical zones, confirm which zones are unrelated each to other. You must perform risk assessment, detect internal connections which are not protected, and so on. It's the longer presentation. It refers to the standard ISA 62443, and during a longer presentation we will dedicate it at least 4 hours to explain the standard, so you will know what is behind this picture. Speaking about firewalls, firewalls are known for many years. Firewall is a hardware device. It can also be a software device. It's usually a programmed device which can screen from which zone data can move to other zone, from which IP address, from which MAC address. So basically this is a sort of programmed guard. There are many different firewalls for lower levels to level 7 of the OSI model, different firewalls. it requires a lot of expertise. However, if you need a firewall, you must find an expert who will define for you what type of firewall you need, for what purpose you need, and take the immediate action. A slightly improved situation is what we call the demilitarized zone. Demilitarized zone is an architecture which combines two firewalls and also combines a specific zone where the data is being inspected, where data is being stored. So what is the idea? The idea is that data can never move directly from the left side to the right and never directly from right to the left. It always must go through the demilitarized zone where data can be stored, where is a terminal server or a deep packet inspection or any type of mechanism which can inspect the data. In some organization they may put a system which we call a sandbox, where data can be temporarily inspected before it's allowed. For example, there are organizations which move every email to a sandbox, the data is inspected, and then the system decides if it can deliver to the intended recipient. So DMZ is a sort of firewall, but a much stronger firewall. Important to say, it must be built specifically in order to match your facility. Another defense, already well-known defense, is what we call the unidirectional security gateway or a diode. This is the hardware-based system which allows data to be transferred just in one direction. For example, you need to only export the data, a vibration data, temperature data, pressure data from the industrial facility to a service provider or to a maintenance person. You can use a diode, and what is important, that the diode is the only hardware-based system which cannot be compromised by software type attack. Obviously, someone can jump through the fence and penetrate to the facility, but when you put a diode, it means that no one who is sitting in the room in the right side can ever penetrate to the industrial facility, because there is only one transmitter on the left side and one receiver on the right side, and data cannot be obviously moved from receiver to transmitter. And there is obviously a single one-way fiber optic link. Again, it requires longer explanation to make sure that you understand when it can be used, how it can be used, how it is working, and so on. Furthermore, we need to talk about anomaly condition detection. What does it mean, anomaly condition detection? It means that you are using this solution when you don't know what to expect. You don't know if you don't recognize that there is a malware. It was not announced. It's a sort of zero-day type malware, and then you are monitoring the condition and changes in the condition in order to detect that something is unusual. So having an anomaly behavior detection is very important, because this will allow you to detect risks and conditions which you don't know how to define. You see a strange person is rotating your house. You have no idea what he is doing, why he is there, but you suspect that if for 1 week he is rotating your house, that person may have an idea, perhaps to break into your house. And as soon as you detect it, you can take an action without knowing what is the intention of that person. So this is anomaly behavior detection. Next topic I would like to talk is the remote access. It was always important. However, it's even more important now during the COVID-19 period, when people from other cities, people from other countries cannot instantly travel and go to the site, and they must do remote type of service. So what does it mean? You need to have a specific deployment, a specific process in order to allow cyber secure remote access. Why? Because you never know who is connecting. If the person who say that he is the maintenance person for Siemens, ABB, Shell, or anybody else, you have no way to identify that this is really true, and you need a secure connection to detect the person, to authenticate the computer, authenticate the person, and so on, to make sure that risks does not happen. So very important to pay attention to what we call as SRA, Secure Remote Access, specifically during the COVID-19 person. And you need to ask yourself, what is our solution in our facility in order to perform remote secure access? Another solution which I just briefly want to mention, because we really do not have a lot of time, I want to leave a long time for questions and answers for all the people who are connecting to this presentation. We need to talk about security, information and event management. This is a computer. This is a facility which was programmed and configured specifically for detecting situation, anomaly situation, attack situation in your facility by collecting data, collecting alerts, collecting logs from different devices and analyzing them. So you cannot expect a person sitting in the security operations center, the SOC room, that he will understand what all these logs are and the alerts are, and he will understand what type of action is needed. No, it's not possible. There must be a security information event management, a SIM facility, which is the computer, which is specifically programmed to collect the data, analyze the data, and perform the action. Speaking a little bit about the standard, there is a broad range of standards depending on to which standard your organization is obliged. Okay, very important. So we speak about the NIST 800, we speak about the NERC for power plants in the United States, in North America. But remember that the most important standard for industrial control systems is the ICE 62443, and during my training I'm going to dedicate 4 hours to explain that standard, so you can use what you learn from this standard in order to enhance the cybersecurity posture of your organization. Obviously, this sentence is talking for itself. Be ready for action when the cyber attack occurs. You need to know the critical zones. You need to know where damage can occur. You need to be prepared for how to perform control shutdown, how to perform safe disconnection from the communication network. You need to know how to act, to whom to report, who is the expert who must be called on site. Many things you need to learn, you need to be prepared. And I want to say, remember this sentence. If you do not assume that you or your organization are targeted and not start searching the attack code, looking for the attacker, you will never find it, meaning that you will never properly protect it. And frankly saying, people who are working in big organizations, oil and gas, water, electricity, they cannot afford. They cannot say we are not prepared. They cannot say we are not protected. Why? Because they must be protected. They must study. They must learn what to do and how to do. So what can be done? Most important is to perform periodic security and vulnerability assessment. Once a year, you go through the facility, you inspect all the installations, you coordinated with the stakeholders, with the managers, how long it will take. You need to identify the vulnerabilities. You need to understand what are the sources of the vulnerabilities. And finally, you need to mitigate the vulnerability. How to mitigate the vulnerability? You must have at least 3 options. You cannot say, let's shut down and build the whole plant from scratch. You cannot do that. You always need to consider the risk, the cost, the consequence for each factor. So cyber security vulnerability assessment must be done by an expert at least once a year. Before we end this presentation, I really would like to remind you, I hope not to be scared, but remind you what is the true cost of cyber breach, a cyber attack. You have administration and legal costs. You will need to collect the research, what happened, why happened, who was in charge. You need to deal with regulations, liability assessment, defend yourself. You need to deal with the damages. You need to explain why we had this damage. Deal with post-incident cost. Explain to the media, explain to investors, upgrade the call center, perform forensic investigation, purchasing a new product and new systems. Finally, remember that when your facility is not working, your facility is losing revenue, you are not selling electricity, you are not providing water, you are not producing gas, you have lost revenue, so major damages. And finally, don't forget what might happen to the position of your managers, the CIO, the CISO, the CEO. Remember, according to the 27001 standard, the top management is responsible for cybersecurity. So this is not something that you can just forget about it. If you are a manager in an organization, you must make sure that you allocate the right budgets, the resources in order to make sure that your facility is protected. I want to leave enough time for questions. And before I go to the last slide, I want to very clearly say that everybody who is interested in recording the version of this presentation, please ask for it. Interested in the slides which are presented, please ask for it. Interested in receiving a longer training, possible. Everything is possible because there are goals that we need to be ready for. So what are the goals? Put security goals into your specifications. Deal only with vendors who take cybersecurity seriously. And when I say cybersecurity, I talk about safety, specifically for oil and gas, electricity and water. Do not compromise on the requirements. If there are requirements, you must say to all your vendors that there are requirements and you are not accepting anything less. Always be ready for tomorrow's challenges and surprises. So thank you very much for listening to this presentation, viewing the slides. You have my phone number, you have my email, you can contact the organizers of this conference. Most important is that you will be prepared for a cyber attack which might happen in every moment. So thank you very much, and I am waiting for your questions.